Hi guys, we're now going to be going to 11.2, which is talking about triangles and how you classify them properly. Classifying just means naming them. So I am going to turn this around to discuss how you classify triangles properly. All right, so it says if you look closely at the Epcot Center Spaceship Earth building in the Orlando, Florida, you may see a pattern of triangles. The triangles outlined in the pattern at the right has 3 congruent sides and 3 acute angles. What type of a triangle is outlined over here? All right, so if you looked here, they did outline one for you. Now, what they're talking about is that Epcot Center in Orlando, Florida, is that big golf ball that you see always is like a big key focus on Disney World. That's what they're talking about. This is like the golf ball of that building. So they just kind of magnified a side of it, and this is what it looks like. So they want to know what is that type of a triangle. So we're going to classify this properly. Now, I do need to talk to you about how you properly name these. So do make sure you write this down. Naming triangles. There's actually could be upwards of 3 words to name a triangle. So in this case, they always want you to look at the sides and name it by its sides. Then they want you to also name it by the angles. And then the last word will always be your triangle. So in order to properly use these and name this, this is what I use, is this chart. So I kind of look at this. This is how I classify just the sides itself. So you have to pick one from this column. When naming the sides, because if this was just like a so if this was like a chart, you would have to pick one of these 3 to name the sides. So one of these words would have to be up here with the sides. And then this is how you properly name the angles. It'd be one of these 3 things. So you would also have to pick one of these for the angles. So now I'm going to want to talk about each one of these. First of all, equilateral triangle. Equilateral, in equilateral, I always hear equal, which means all sides are the same. All sides and angles are the same. So this is an equilateral triangle. So it has how many equal sides? Well, it has 3 equal sides. We're just naming the sides right now. So this is just an added thing. On equilateral triangles, all angles are also the same, but we will get to that in this part. But I do want you to know that an equilateral triangle has both of these, but that is not how we properly name the angle. This one just names the sides. So an equilateral triangle always has 3 equal sides. An isosceles triangle has blank congruent sides. Well, on this, I hear in isosceles, I always hear the word eye, which means like your eyes, That's how I remember it. So in your eyes, how many eyes do you have? Well, you have 2. So therefore it has 2 congruent sides. So that is our definition of an isosceles triangle. Now the book tries to say that equilateral is also an isosceles. So I always think of it like as an isosceles. It has eyes, they're on the same length. And then here's your nose and so on like that. This book actually says that isosceles is also, it says like it could at least have just 2 sides. So they're trying to say that equilaterals are considered isosceles because it does have at least 2 sides that are equal. And in Geneva, I actually went to the state of Ohio on this and talked to them about this. They said that it is up to the district how they want to interpret this. So our district, when I went and talked to all the other teachers up at the high school and the middle school, we all came to a conclusion that we are just going to use isosceles as just being 2 congruent sides, and equilateral is just 3 congruent sides. So isosceles and equilateral will never be the same. So keep that in mind. They are separated in our district. So the state of Ohio, on the state test, it does allow, it will give you both answers if you chose the one that are separate and then the ones that are together, because some districts do go by a different definition than we do. So this is going to be 2 separate things. An isosceles will not be considered an equilateral, and an equilateral will not be considered an isosceles as well. So they will be 2 separate things. So if it has 3 equal sides, it's automatically an equilateral triangle. If it has 2 equal sides, it is automatically an isosceles triangle. Now, a scalene triangle is what this one is called. If you look here, how many sides are the same? Well, there is 0. So I think of it as like scales at like a doctor versus at your house. If you always go on scales at home and then you go to your doctors, like they're never right. So that's how I remember it, is like no scales are the same, especially when the doctors versus the home scales. So that's how I remember, but you can think, people like to say scales on like on a snake, they're not all the same as well. You could say that too, if that helps you as well. So this is just talking about the sides. So each triangle will need to have one of those words need to talk about just the sides. So we will talk about that soon. And then each triangle also needs to have a word for its angles. So you also have to pick one from this column as well. So a right triangle has one 90-degree angle, or a 90-degree angle is also called a right angle. So this is called a right triangle because it just has to have one angle that is 90 degrees. If just one of those angles is 90 degrees, then it is automatically a right triangle. So you will see this kind of looks like a little box. That is your definition of it being 90 degrees. So only one angle is 90 degrees. Is all that definition is. So if one angle is 90 degrees, it is automatically a right triangle. Now, an acute triangle has 3 blank angles. So it has all acute angles. Now, how I think of this is little angles. Like we all say like, oh, they're so cute. It's like puppies or babies because they're all little. So that's how I remember acute. Acute means little angles. So all three sides, oh, sorry, three angles, all three angles must be less than 90 degrees. But more than 0 degrees. So if they're all from 1 to 89 degrees, all in that range, then that means it is automatically an acute triangle. All three angles must be smaller than 90 degrees in order to be this. And then an obtuse triangle has one blank angle. Well, this is obtuse. How I remember it is obtuse. You kind of hear like obese, and obese just means large, very large. So that's how I remember it, but you guys can remember however you would like to. So in order to be obtuse, just one angle just one angle needs to be larger than 90 degrees, but smaller than 180 degrees. So in order for it to be obtuse, just one angle needs to be 90 degrees, bigger than 90 degrees. Here, in order to be an acute triangle, all three must be smaller than 90 degrees. And then in order to be a right triangle, only one, or you could say only one or just one angle needs to be 90 degrees. All right, so now that we need to classify this triangle outlined in this pattern, can be classified by the lengths of its sides of a triangle. So looking at the sides, now it already told us it has 3 congruent sides. So that means 3 congruent means same size and same shape. So they're all equal. So therefore they are all equal. So you would have to look at this one. It's got to be one of these because this is the one that classifies just the sides by itself. So it's either got to be equilateral, isosceles, or scalene. Well, if they're all 3 sides are equal, that means it's got to be an equilateral triangle for the sides. And then you have to classify it by its angles. So if you look over here, it said that 3 acute angles. Well, if there's all 3 acute angles, then it has to be an acute triangle. So therefore, this is an equilateral acute triangle, is what people would say, or people also just say equilateral triangle because all equilaterals are acute. So they don't normally say these two together, but you can. All right, next. It said that they wanted you to look at this and then use a protractor and see in a ruler to see what these would have been. So they wanted you to label each side and measure each angle. Just because of time, I am not going to sit there with a protractor to do that. So I'm just going to tell you what it comes out to be. This comes out to be 3 centimeters for this side. This one is 5 centimeters. And this side was 4 centimeters. And then looking at the angles, this one would have been 120 degrees. This one is 35 degrees, and then this one is 25 degrees. So then they wanted you to classify this properly. Again, we got to name the sides. So we got to pick one from the sides. So if you look, all the sides are not the same. So which one of these, if you need to come back, tells us that there are no sides that are the same. This is your scalene. So we're going to write up here, scalene. Is scalene, and then you're going to look at the angles. Well, this one is 25, which is less than 90. This one is less than 90, but this one is bigger than 90. So therefore, it is not 90 degrees. So it was bigger than 90. So it is this one. One of them is obtuse. So therefore, it is an obtuse scalene triangle or scalene obtuse triangle. It doesn't matter how you say it, but it's these three words together. So scalene obtuse triangle, or you could have said obtuse scalene triangle, same thing. So that is how you go about classifying these properly. We are not going to do this part because they wanted you to draw your own triangle, but on the state test, they will be giving you triangles. You just have to classify them. You don't have to draw them yourself. So here it says to classify this triangle, you're going to first pick one of these for the sides. So pick one. And then this names the angles. So you got to pick one of these when looking at the angles. So first we're going to look at the sides. Well, the sides, none of them are the same. So therefore, none of the sides that are the same is scalene. So this one is scalene. And now you're going to look at the angles, 51, 75, and 54. So none of them are 90 degrees or larger. So therefore, they're all smaller than 90 degrees. So all three are smaller than 90 degrees. Well, that means that they are all less than 90. So they are all acute. So therefore, this is a scalene acute triangle. Okay, so then next, we are again going to pick one for the sides. So if you look at the sides, it has one hash mark, one hash mark, one hash mark. So they all have the same hash mark on each of these. So that means that they are all the same. So if they're all the same, what side has all the same? It is an equilateral. So this one is your equilateral. And now we're going to look at our angles now, and they are all the same. Now, here's the thing. When they are equilateral, remember when I said in the previous lesson, I said that each triangle is always 180 degrees. Well, if they are equilateral, that means that all the angles are the same as well. So if we want to divide this evenly by 3, we did do this in a previous lesson. If you divided it by 3, it came out to be 60 degrees for each one. So therefore, at an equilateral triangle, they're all 60 degrees. So therefore, since all these are 60 degrees, they are all less than 90 degrees. So since they are all less than 90, it is considered an acute triangle. So an equilateral acute triangle. And you can also, you normally don't hear equilateral acute. You usually just hear equilateral triangle because everyone should know that it is automatically going to be acute. All right, here, the next one. If you look here, there is one hash mark and one hash mark. So that means that these two are the same, but then this one doesn't have the same hash mark. So therefore, how many sides are the same? There are only 2. So what has two sides that are the same, it is known as an isosceles. So isosceles. And then we got to look at our angles. Well, this one is definitely not 90 degrees or bigger, and neither is this, and they're actually the same. And then they're telling you that this one is actually 29. So they are all smaller than 90 degrees. So therefore, it is acute. All right, so now I want you to try these two on your own. Again, you are just writing one of these, you're picking one. This is to name the sides. And then you are choosing one of these to name the angles. So you need one from these and one for the angles. So go ahead and pause this and try 4 and 5 on your own. Okay, so if you looked here, you should have looked at these sides. Well, there is two that are the same, so it is isosceles. And then here it was 27, 126, and 27. So therefore, one of them was larger than 90 degrees. So therefore, it is automatically an obtuse. So it is an isosceles obtuse triangle. Here, you should have looked at the sides. None of them are the same, so it was scalene. And then if you looked at the angles, again, one of them is larger than 90 degrees, so therefore it is an obtuse. So it was a scalene obtuse triangle. Okay, next it says, circle the figure that does not belong and explain. So if you look here, I see this one has a right angle. This one just has all same angles and same sides. And then this one has a right. So therefore, the one that does not belong is this one. And they wanted you to explain. The second triangle doesn't have a right angle. So it is not a right triangle. All right, now this one, it says draw two equilateral triangles that are congruent and share a side. What polygon is formed? Is it a regular polygon? All right, so they said to take two triangles that are equilateral and have it share a side. So I'm just gonna move this. So there is mine, not the best, but it is that I actually did better on this one. Here is what it was, what polygon was formed. Well, it is a four-sided shape, which is known as a quadrilateral. So we made a quadrilateral. And now we got to look at the angles themselves. If you look here at this angle, and this angle are definitely not the same. So this one should have two, and then this one only has one rainbow. Same thing here, that would be your one. This would now have, this one would be the same here. So therefore, is it a regular polygon? No, it is not. It isn't regular because the angles are not the same. Okay. Now we're going to go on to the next one. It says Shannon said that a triangle with exactly two congruent sides and an obtuse angle is an equilateral obtuse triangle. Describe her error. So it says it has exactly two congruent sides and an obtuse angle. All right, so the angle is obtuse. So then if the angle is obtuse, it is an obtuse triangle. But then it said only two sides that are the same, and that is isosceles. So she said that it was an equilateral obtuse triangle. Describe her error. So it is, the error was, it isn't an equilateral triangle because it had only two sides that are the same. Not three. So it is an isosceles obtuse triangle. All right, now I want you to try 9 on your own. So please pause this and try 9. All right, so on 9, it says Kelly drew a triangle with exactly two congruent sides and 3 acute angles. Which of the following accurately describes the triangle? Mark all that apply. So it has two congruent sides. Well, two congruent sides is automatically isosceles. It has 3 acute angles. Which one is that? Well, all 3 are acute. That means it's automatically an acute triangle. So therefore, this was an isosceles acute triangle. All right, now, here's the next thing. It just said that they wanted you to try to identify this. It says forces and balances. What makes triangles good for construction of building or bridges? The 3 fixed lengths of a side of a triangle, when joined, can form no other shape. Not when pushed, triangles do not bend or break. So they're saying if that was the force coming down on it, what could happen is it could have bent that way or this way. So it was bending one of those two ways. Now they're saying on a force, if you're forcing down on a triangle, it does not bend or break. So they want you to classify the structures below. They want you to look at this triangle right here, and they want you to see what does it look like to you. This is my issue with it. I don't like these type of questions because generally, if you are given a question like this on the state test, it will give you hash marks or symbols telling you what is the same and what is not. And this one is not properly doing that. So, but I will tell you that this side and this side are the same. So therefore, this one is isosceles. And then they wanted you to say, like, turn this around and look at it. So if I turned it around And it's saying that this would have been a right angle. So they wanted you to say right, but to me, since they did not give that symbol, and on the state test, if they don't give you that symbol, then it is not a right angle. So it is actually an acute one. So therefore, I would have accepted isosceles acute triangle, or how they wanted it is an isosceles right triangle. Here, they want you to look at this. They wanted you to see that, yep, it is definitely on a straight line, and this is definitely a corner. So therefore, that is automatically a 90-degree angle. So that is right. It is a right triangle. Now they wanted you to look at the sides, which is very hard to see here. So I'm not a big fan of this. This is definitely smaller than this, and then this one and this one are not the same. So none of these are the same. So they wanted you to see that it was scalene. All right, so now you have your homework. Again, on your homework, you have to pick one of these for the sides. So this names the sides, so you got to pick one. And then these ones name the angles. So you need to pick one of these. All right, so they're showing you right here. They're showing you the sides, an 8, a 6, and a 10. Well, none of them are the same, so it is scalene. And then they want you to look at the angles. Well, it's 53, 37, and then it has the symbol. Remember, when you have this symbol, it is automatically 90 degrees. So since you have exactly a 90-degree angle, that means you have a right triangle. So therefore, this one was scalene right triangle for this. You will have 2, 3, 4, and 5 for homework. And then I'm going to do 6 with you. This one says 23, 20, and 13 are the sides. Well, if you look, none of them are the same. So therefore, when you have none of them that are the same, again, you can go back to this chart on page 643 to help you. None of the sides are the same. So we're going to look at the side column. None of them that are the same. This is a scalene triangle. So this is scalene. And now we got to look at the angles, 62, 72, 46. So none of them are 90 degrees or larger. So they're all smaller than 90 degrees. So therefore, if they are all smaller than 90 degrees, it is an acute. So therefore, this one is a scalene acute triangle. All right, next. It says Mary says that the pen for her horse is an acute right triangle. Is this even possible? So this one says acute right triangle. So let's see if it is possible. Acute and right are only 2 words that describe an angle, but nothing is describing a side. So therefore, this is not possible. So no, because a right and acute are only words to describe angles. There was nothing talking about the sides. Okay, next, Karen says every equilateral triangle is acute. Is this true? Well, we've actually already talked about this, and this is, yes, very true. All angles on an equilateral triangle are acute because 180 degrees divided by 3, because they are all the same, would be 60 degrees. Each one would be 60 degrees, which are all acute. So therefore, this is a true statement. Okay, you will not do 9. So let's go to the back. On the back, I want you to do all, I want you to do, actually not all of them. You're going to do 2, 3, 4, 5, and 6. And I'm going to do number 1 with you. If 2 of a triangle's angles measure 42 degrees and 48 degrees, how would you classify this triangle? Right? Either acute, obtuse, or right. So in this case, it says that 2 of them is, there's one that was 42, one that it is 48, plus you have another side. And remember, all triangles, we already talked about this, comes out to be 180 degrees. So if you wanted to figure this out, you should be adding up these 2 to see what this comes out to be. So 48 plus 42 is 10, carry your 1, this would be 9. So this is 90 degrees. So 90 degrees plus what is going to give you 180 degrees. So we need to figure out what this is. Well, to figure this out, I should subtract off 90 to see what is remaining, because I'm working backwards. So this would be 0, 8 minus 9, you can't do that. So you have to borrow, so now it's 18 minus 9, which is 90. So the last one, n, has to be a 90-degree angle. So therefore, since one of them is 90 degrees, that means it is either an acute, obtuse, or right. It is definitely a right triangle. Okay, and that is it for 1.2. All right, bye guys.